Pili. Fimbria are little hair-like appendages. Little hair-like appendages all over the cell, smaller than cilia. Notice many gram-negative bacteria. That does not mean all, many. And they allow adhesion to other surfaces, to other cells. These are for stickiness and adhesion. And you might kind of wonder, if not now then later, you might kind of wonder, well, don't capsules do that? Can't capsules do adhesion? Yes, sometimes. So generally, what this means is, you're not going to have a bacteria with both a capsule and Fimbria. You've heard me say all quarter long, there's just lots of variation and stuff. This is an example. So there are different ways of sticking to other surfaces. Having a sticky capsule is one possibility. Having Fimbria is another possibility. So it wouldn't have both, because the Fimbria would be inside the capsule and couldn't stick to anything. Pili. That plural, the singular, pilus. I have to backtrack a little on this. Obviously, you're all perfectly aware the bacteria do not have nuclei, but they do have DNA. All living things have DNA, we all do. It's just that for the bacteria, it's not in the nucleus. It's just in the cytoplasm. And it turns out that the bacteria have a single chromosome that's in a circle. So it looks like a nucleus, but it's not. It's a single chromosome that's in a circle. Okay, fine. But what's unusual about bacteria compared to us is that bacteria also have extra pieces of DNA outside the chromosome. See, we don't have that, but bacteria do. These are called plasmids. Plasmids are extra pieces of DNA outside the chromosome. So they're just loose in the cytoplasm. Now, in many cases, we know what the plasmids do. Sometimes we don't. But that just means we don't know what it is. There probably is a function, or it wouldn't be there. But in some cases we know, some cases we do not know. But there's one in particular called the F plasmid. The F plasmid. The F stands for fertility. Fertility. And not all bacteria have this plasmid. Some do, some don't. So if the bacteria does have the F plasmid, it's called F positive. If the bacteria does not have the F plasmid, if it does not have the F plasmid, it's F negative. So F positive, F negative just doesn't have the F plasmid or not. Some do, some don't. Yeah.
So you just always have, to call it positive?
If it's got the F plasmid,
Yeah,
yeah.
and then if it doesn't have it, you
F
just
negative.
always just call it.
Yeah. Yeah. Okay, so what happens now, what the F plasmid does, in the presence of an F negative bacteria, the F plasmid becomes activated. Remember, it's a piece of DNA. DNA have functions. In this case, the F plasmid forms this long tube called the pilus that connects the two bacteria.
F positive and F negative.
Yes.
And the plasmids do this.
The F plasmid. Yep. And then what happens is that the F positive bacteria makes a copy of all of its DNA. It copies all of its DNA and ships it out. So a copy of all of the F positive DNA goes over to the F negative bacteria.
So it's called transfer. And this
Hang on.
is a pilus.
Yes.
Is there a name for that process?
There is, but hang on for a second, but there is a name. So anyhow, so the copy of the DNA is being shipped out to the F negative. Now remember what I said to you the other day about binary fission, that the parent cell will make, will kind of duplicate all of its DNA, and then half goes here, and then the cell divides. So all of the daughter cells have exact copies of the DNA of the mother cell, and therefore no genetic diversity. Well, that's what's going to happen here, that most of the DNA here is identical to the DNA here. Same cell, same type of cell. But there are some differences. For example, the F plasmid is here, but not here. So basically, the F negative cell is going to accept all the DNA, or essentially get rid of, decompose, whatever, any DNA that it already has. So any copies that are shipped over that it already has, it gets rid of it. Any new DNA that it does not have, it keeps it. So there is some transfer of DNA, although it's only one direction. It's not really a transfer, it's one direction. But there is some transfer of DNA into a new cell. So that is how bacteria can get new DNA from other cells. So they do achieve some genetic diversity. Brian was asking about the name of this. It's called conjugation.
That whole process
Yes.
of plasmids
Yes, the whole
formations
process.
into.
Conjugation. Conjugation is the transfer of the DNA into the new cell, and basically the new cell getting new DNA. And that is how bacteria can achieve some genetic diversity, by getting new DNA. Now, the original cell isn't getting anything. It's all the F negative. Now, it's almost impossible not to make an analogy with sexual reproduction. I mean, you've got a tube forming, you've got DNA being transferred and so on. It's hard not to, pili are used as sexual organs, et cetera, et cetera. But in honesty, the analogy breaks down pretty quickly. For one thing, this is not reproduction. You're starting with two different cells, you're ending with two different cells. So it's not reproduction. Second, this F negative bacteria, what has happened to it now? Yes, good for you and you. It has become F positive. It now has the F plasmid. So it's now become F positive. It's no longer F negative.
So now it can transfer its DNA to another F negative cell.
Sure, it's F positive.
And so what happens to the original F positive cell?
It's still F positive.
Will it continue to transfer DNA in the
Why not?
residence?
Why not? I mean, literally, why not? It's
Right.
F positive. So sure it will. The pilus will eventually go away. And then both cells just go off and do what they want to do. But again, going back to reproduction, clearly, if most of us, when we do sex, we don't really change genders afterwards. You know, we kind of stay the way we are. These guys are changing gender. Going from F negative to F positive. So that's why I say the comparing with sexual reproduction, it breaks down pretty quickly. But still, there is a transfer of DNA. Yes.
So after a while, the negative is going to be non-existent.
No, good question. I'll rephrase, but she's basically asking, won't you run out of F negatives after a while? No, because after all, binary fission is occurring all the time. You're always making new cells. And basically, there's more binary fission than there is conjugation. So you never really do catch up. But in theory, yes, and in practice, no. Yeah, yeah. So that's why I say there are some mechanisms for genetic diversity. And in fact, there are two more, which we'll do at a later time. Techniques how bacteria can transfer DNA. So what we still have left to do, we're not going to have time tonight, but we'll have to do it next Tuesday, is talking about the cell wall. So we should have no problem finishing that on Tuesday. I'll have time for a review of sorts. Remember, my notes are your review. You know, all that a review does is tell you what we've studied. Well, my notes certainly tell you what we've studied. But we didn't do chemistry. Well, we did chemistry, but we don't have notes for chemistry. I will review with you the chemistry. I will go over that with you.
On Tuesday,
Yes. I have to, because the test is Thursday. So yes,
and that's the beginning of the class.
yes,
And then we have lab,
yes,
no lecture.
correct. Good. It's a perfect world, yes. So, yeah, so that pretty much summarizes it. So anyhow, we're going to do lab now, but and no quiz. I'm not that mean. You know,
Oh, no
and
quiz
we
on
do the
Monday?
same week.
Oh, okay.
No, we don't do that. Anyhow, again, we're going to start lab now. If you come up with questions over the weekend, just email me. And I will check. So I'll get back to you. They're called my notes. That's your study guide.